Hey guys, so far we've looked at all kinds of factoring. Factoring by grouping, that's a nice one that allows you to check it while you're working. We even looked at a little factoring with modeling. We've looked at perfect square trinomials and their tricks and difference of squares and their tricks. But sometimes you just get to a trinomial that is not factorable. So if something is not factorable, we have two different methods that we can use. Basically, if it's not factorable, it doesn't have a nice solution. And by nice solution, I mean a nice integer answer or a nice fraction answer. Yes, fractions can be nice. It can be simplified nicely. So let's look at a couple of examples. So this first one, x squared plus 16x minus 9 equals 0. Okay, same rules apply. It's got to be in standard form. It's got to be set equal to 0. Check, A, B, C, and set equal to 0. Check and check. Okay, so for completing the square, this is going to be another one that's a little procedural. There are a few things you need to make sure happen. First thing, make sure A equals 1. So in this case, x squared, yes, A is 1. Awesome. Now, normally I would go to factor and I'd say A times C, 1 times negative 9. Factors of negative 9 that give me 16. The biggest factor is 1 and 9. The biggest I could possibly get is 10. So I can quickly see this is not factorable. But that doesn't mean there's not a solution. So to find the solution, we're going to use completing the square. So then we move on to step 2, and it says move C over. So let's identify our C term, so this minus 9, and let's move it to the other side. So we're going to add 9 to both sides. So we have x squared plus 16. I didn't want that color. And I'm going to leave a blank, and you'll see why in a minute. And then I have my positive 9, and I'm going to have another blank again. So what I'm going to do is we're going to create a perfect square trinomial, one of those that factored really easily. Why do you ask? Let's wait and see. So to do this, we're going to do the jingle. So to create a perfect square trinomial, we half it, we square it, and we add it to the other side. Half it, square it, add it. Half it, square it, add it. I feel like the old school bop it's like that's the tune that's in my head right now. Sorry. All right. Half it, half what? It's all about the B term. So we're talking about the B term. So when I look at positive 16, what's half of it? 8. And if I square it, what's 8 squared? 64. So I am adding 64 to both sides. Why did I do it to both sides? Because remember, this is still an equation, okay? We have to keep it equivalent. So if I'm adding 8 squared to one side, I have to add it to the other. Keep everything in balance. Now, why did I do this? Well, because I can quickly factor this. I bring down x, I bring down positive 8 squared equals 9 plus 64, 73. What? Remember, if we were to factor this, x squared plus 16x plus 8 squared, so plus 64, x times x gives us x squared. Don't write this, I'm just showing you why. X times x gives us the x squared. 8 and 8 gives us the 64. If we add them, then we're going to end up with our 16x. So I'm just, instead of writing it out twice, I write it squared. Why? Because I want to solve. Okay, so if I go to solve, look, I only have one x. So I just treat this like a regular equation and solve for x. So when I do that, first thing I need to get rid of is this pesky little squared. Because if I were to square everything, I'd end up back where I started. So I want to get rid of the squared. So what's the opposite of a squared? Square root. So I take the square root of both sides, and I'm left with x plus 8 equals the square root of 73. Now, quadratics tend to have two solutions. Think about that u. If we graph the u, they can hit the x-axis up to 2 times. Do they have to have two solutions? No, they don't, but they can. So to get those two solutions, when we take the square root, we write plus or minus the square root of 73. If that confuses you, let me give you an example with a smaller number. The square root of 4, we think of that as 2, right? However, this is really a variable. So if I said x squared equals 4 and I take the square root, what squared equals 4? Yeah, 2 squared equals 4, but what else squared equals 4? Negative 2 squared also equals 4. That's where we come up with those two solutions. So because there's a variable involved, I could have potentially two things that I'm plugging in here to get the correct answer. So to account for both of those, when we write it out, we write plus or minus the square root of 73. Because again, we could have up to two solutions. If there's only one, it would cancel out once we took the square root. So let's go ahead and continue solving for x. So I'm going to subtract 8 from both sides. So x equals, you can write this a couple different ways. Normally how you'll see it is the negative 8 you'll write first, and then you'll follow it up with plus or minus the square root of 73. Okay? That is not the only way. You could also write this plus or minus the square root of 73 minus 8. That's also equivalent. Again, primarily, you're going to see it this way. Okay, now we have solved for x. The only way you could simplify this more is you could plug it into a calculator, so you could do negative 8 plus, and then find the square root of 73 and figure out what that is, and then your second one, negative 8 minus the square root of 73. So that would give you your two solutions. Or always look at this radical to see if we can simplify this. 73 is a prime number, so I know I cannot simplify 73, but we always want to look, because especially in a multiple choice or select all that apply, if you don't see your answer, don't assume that you're wrong. You potentially could keep going to simplify. All right, I know that was a lot of new information, so let's go ahead and try another one. Our next quadratic is 2x squared minus 20x equals 8. So 2x squared minus 20x equals 8. Okay, did I write it down right? Yes. All right, so let's follow the steps. So first, make sure a equals 1. So does a equal 1? Nope, a is 2. So how can I cancel out this 2? Well, 2 times x squared. So we're going to divide everything by 2. So x squared minus 10x equals 4. I did strategically leave a break in there. I'm going to explain why in a second. Because what's step 2? Move c over. Well, our c term, our constant, is already on the other side, so that step's already done for us. So I'm going to go ahead and fill in my blanks. That way we can go ahead and do the jingle. All right, so we're looking at our b term. So half it. What's half of negative 10? Negative 5. Half it, square it, add it to the other side. Negative 5 squared is 25, so I'm adding 25 to the left, so I better do it to the right. Okay, so let's go ahead and factor so that we can solve for x. So we have created that perfect square trinomial. Why I leave it like this? So I can kind of cheat a little. I can just bring stuff down. I'm going to bring down my x, And notice I keep my sign, so it's negative 5, so minus 5 squared equals 4 and 25, 29. Okay? Because x minus 5 times x minus 5, the minus 5x's would give us our negative 10x, and when we multiply them, we get our positive 25. So let's go ahead, isolate x. What do we want to get rid of first? You guessed it, that's squared. So I'm going to go ahead and take the square root of both sides. So I'm left with x minus 5 equals, remember, two solutions, so plus or minus the square root of 29. Fantastic. One more little step, get rid of this minus 5. So we'll add 5 to both sides. X equals 5 plus or minus the square root of 29. Now again, I do want to look to see if I can simplify that radical. 29, 2, 3, 4, no, it's not divisible. So it is a prime number, its only factors are 1 and 29, so I can't simplify. So these are my solutions. Unless the answer, unless a question asks you to round to the nearest hundredth or something like that, then this is literally the only answer you need. That's as far as you need to simplify. Okay, so there's one more question. It is 2x squared plus 10 equals negative 8x. I would love for you to try and pause the video and try this one on your own to see if you can get it. And if you get stuck somewhere, then unpause, but try it on your own first. Okay, welcome back. So, hopefully you went back to your steps and looked at step 1. Make sure A is equal to 1. No, by golly gee, it is not. So, let's get rid of that. 2 and divide every single term by 2. So I'm left with x squared plus 5 equals negative 4x. Beautiful. Now, move c over. Well, we've got more than c to move over because look, our b term is on the opposite side as well. So we got to do a little bit of moving here. I'm going to add my 4x to the left to move it back over with my x squared. And I'm also going to subtract 5 from both sides to get the c on the other side. So x squared plus 4x, I'm going to spread this out a little bit more. X squared plus 4x, leave my space, equals negative 5. All right, then we go to do our jingles so that we can create a perfect square trinomial. So I'm looking at that b term, so half it, positive 2, square it is 4, add it to the other side, 2 squared is 4. Okay, so we have x squared, oh wait, no, we need to factor. So I have x and a positive 2, so plus 2 squared equals negative 5 plus 4 is negative 1. Okay, cool beans. So now let's go ahead and solve. So first thing, get rid of that squared. So I'm going to take the square root of both sides. So I have x plus 2 equals, wait a minute, square root of negative 1. Can I take the square root of a negative? 2 times 2 is 4. Negative 2 times negative 2 is 4. No, there's no way we can multiply two of the same numbers to get a negative number. So this does not work. This quadratic has no solutions. Now, if you wonder how that works, in a quadratic, if we go to graph a quadratic, remember, solutions are just x-intercepts. So where does it touch the x-axis? Well, obviously this quadratic, now a is positive, So I know it's a smiling parabola. It's happy. So this parabola is somewhere above the x-axis, so it never actually touches the x-axis. That's how we get no solutions. So don't be fooled. If it tells you it equals a negative number, we can't take the square root of a negative number. Don't always stop at this step though, because sometimes if we add that c term to the other side, sometimes it'll become positive, so it will work. So don't try and stop too quickly. Make sure you get down here and make sure it actually is illegal. So for this problem, there are no solutions, no x-intercepts, no roots, no zeros. You know, we have all those terms for that one thing. All right, so go ahead, try it yourselves. Let's see how you do.